everyone, it's Judy Warner. Welcome back to our next edition of our IMS 2023 Tailgate Party. Today we're pre-gaming with a couple RF experts from Samtec. I'm joined by David Beraun and Steve McGeary at Samtec, and we're going to talk about how they are pushing the limits of high-frequency connectivity. We're going to talk about sort of solutions and problems that are emerging, and then they're also going to talk about what they're going to be showing at IMS, the technical presentations we're going to do, and then we're going to share with you a bunch of technical resources, so whether you're there or not, you can tap into that. Thanks so much for joining us, and make sure if you are coming, you go over to booth number 1855 and come say hello. Hope to see you there. Now let's jump into our conversation with Steve McGeary and David Beraun. Hi, David. Hi, Steve. Thanks so much for joining us today. I'm excited to talk to you about everything RF today.
Morning, Judy.
Great to be here, Judy.
Good to be with you. Well, for our listeners' sake, can you each take a moment and tell us a little bit about your professional background and then a little bit about what you do at Samtec? David, why don't we start with you?
Yeah, so my name is David Beraun. I'm with the RF group, product manager for the RF team here at Samtec. Been here for about 9 years, came straight out of school.
Steve?
My name's Steve McGeary, and I've been in the industry since the early 1990s, 1991. I've been at several different companies, but had a company called Precision Connector, which was acquired by Samtec in 2018, and I've joined them since that time and continue to work with them. I'm Director of RF Business Development and Product Management.
Okay, well, both of you, I want to talk to you about RF. We're just, days or weeks ahead of the International Microwave Symposium in San Diego, and I know you're going to be there, I'm going to be there, and so I thought our audience would want to learn a little bit about sort of pervasive problems you see specifically around RF and high frequency application and what maybe obstacles RF engineers are facing right now in regards to high frequency interconnects.
Yeah, certainly. One of the biggest things I'm sure you're familiar with always is, as data rates continue to increase, it's always the challenge of how do you be able to solve those problems to be able to get more throughput through the product. So one of our products that we have mainly focused around test and measurement is our Bullseye. It really, we had customers coming to us, 112 PAM4, for the high-speed SerDes was one of the big drivers for, our previous product. And, as customers are moving to 224, as well as, there's a lot of automotive radar applications, up in that 70 gigahertz range and 70 plus, there was a need for a product that went, up and above. So what we have that we developed was our BE90 product. It's our 90 gigahertz solution, in which it has all the great aspects of a Bullseye product, which allows you to have a high density solution that mates directly to a printed circuit board. So you get all the perks of being able to place very closely to your silicon, your DUT that you're testing, while being able to support those new higher frequency needs that are coming up within the industry.
Good. So, Steve, you've been in RF forever, and specifically around connectors and high-speed interconnects. What sort of things do you see as problematic, and again, things you're leaning into into that space to solve these issues?
Well, the interesting thing is RF, up until about, say, 10 or 15 years ago, was primarily all military-based, and that's not the case anymore. There's a lot of commercial applications. The world is so interconnected now. Everything from our cars, our homes, our cities, everything's interconnected, all this data throughput that's going through, and it's requiring higher and higher frequencies. And in addition to that, everything's getting smaller. So as you get smaller packages, we're down to where now we go up to 110 gigahertz with a 1 millimeter connector. Well, a 1 millimeter connector is simply a smaller version of all those big coax connectors that we've been selling since really the 40s is when coax connectors were first found. But much smaller, much tighter tolerances. And that's great. But now that everything is commercial oriented, there's a big cost driver as well. So now how do you make those connectors and those interconnects perform up that high in frequency, reduce the cost? Usually, in order to get performance, the tolerances have to get smaller and smaller. So those are some of the trade-offs and a lot of the difficulty that the RF world is trying to deal with today, as now RF is really acceptable with a lot of different commercial applications, which wasn't the case a decade or so ago.
Yeah, so let's just talk about that for a moment. Is sort of from a very high level things I'm hearing, because I had a little stint where I was completely immersed in RF microwave PCBs, both at the bare board level and at the assembly level. And it's why I started blogging, really, is because I saw all the knowledge disconnect and the gaps in the learning. And what are you guys seeing as far as people that are being, as I say, pulled, dragging and screaming into RF and not having those skills but needing to integrate it when there's all these interactions or the problems with interconnects? Like, I know it's sort of a high level question, but I'm interested in your perspective.
Because I come from the RF world, Samtec was primarily a digital company before they really took on to bring RF products amongst their offering. So you have different engineers that the worlds are colliding now.
Yes.
A lot of times the same terms are looked at in a different sense. We're all trying to do the same thing. They talk about gigabits per second speed. We talk about frequency.
Right.
So you've got that, but it's getting less and less. Now most of the digital engineers are for the most part more familiar than they were 10 years ago with RF. You got a taste of it. A lot of the RF guys now are now seeing that their applications are used in the digital world. So there's a lot of cross learning, and it's getting better. But those are, really two cultures that collide, and probably 5 or 10 years, all of this will go away. And like I said, it's getting a lot better. But that's really what we've been dealing with.
Interesting. Well, I'm glad to hear that engineers are coming along, because I think when I first started, it was just kind of a hot mess. David, as Steve said, some of these alignment features are getting so tiny. So how do you deal with that kind of precision alignment? You as a product manager, like, how are you addressing that?
Yeah, so one of the biggest challenges really is, as Steve was saying, frequencies are getting up, all the feature sizes and everything, and the tolerances that are required are becoming much, much tighter than before. And exactly as you said, Judy, right? The engineers are, not wanting to get into this realm, and they're kicking and screaming, and they absolutely do not want to, have to deal with some of these challenges. And so that's what it leans on us, to provide product that makes it as easy as possible. As that's always going to be the challenge. So one of the big things, I'm going to use an example of vertical compression connectors. I'm sure most people listening have dealt with that at some point in their past. When working with the test board, it's very, very common. Samtec, what we did on one of our products was basically added a additional alignment feature to be able to support some of these higher frequencies and offer a better repeatability. And I think that's one of the biggest challenges, is how do you give a customer and an engineer something that they're used to dealing with, that's very common. They're familiar with it, they know how to use it, and make an update, make a tweak that makes it easier for them, work for a application that it may not have in the past. Our vertical compression connectors, basically what they do is they use a fiducial on the board with a precision milled notch within that flange that you'll typically see, and that allows them to line up everything perfectly, between the PCB pad and the connector itself.
Okay, well, Steve, if I'm not mistaken, we did a podcast about a year ago, and I think you guys gave me a paper about alignment. Maybe I can get you to share that link for me, so our audience can can tap into that. 'Cause, am I right? Do I remember that correctly, that that paper was about alignment?
We do, and if they go to our website, in our blog section, there's a whole write-up about the alignment features and everything.
Okay.
It's kind of a big deal. We have a patent pending on it. It's really a
Okay.
simple solution, but nobody else has done it. So we've got a patent pending on it, and we're promoting it heavily at IMS this year because now we've added the grooves. We didn't have the grooves last year when we were
Okay.
actually showing the product. It's been an improvement to an existing product that we sold, and so like I said, if they go to the website, they can get all the information they need on the grooves.
Yeah, and that paper, Steve, by the way, it definitely goes into more than just alignment as well. So it's really focused on, wideband RF launches. So what are the tips and tricks that are necessary, when starting to get towards these higher frequencies to be able to have a product, not just from the connector side, but from the launch within your PCB to work as well as possible. So definitely a good tool, to be able to have in your back pocket whenever, starting to move towards these types of frequency ranges.
Well,
And
go ahead.
if I can just reiterate kind of what David was saying, this is a perfect example of where in the lower frequency products, they could get away with a lot of stuff that as soon as the frequencies go up, just a little bit of misalignment has a huge effect on the performance of the parts. So a lot of things have to be taken into once you start getting into precision. And again, this was a simple solution to that problem, but it's one of those things where a lot of the guys that have been working with PCBs and connectors and SMAs and stuff where they were just soldering on the board, they never had any issues. But as soon as you start getting into high frequencies, it's a huge deal as to whether they perform.
Is it clear to the engineers when that misalignment is happening, or do they just suddenly go, it's not working? What's happening?
It's hard because the screws come from underneath the PCB, and when it's compression mounted onto the board, you can't really see it. There's a lot of blind factor. That's where the alignment grooves gives you total visibility of getting it aligned. So a lot of times, they would see the performance was suffering. They may not know it was misaligned, but then there was a lot of tweaking and playing, and this takes all of that out of it. It makes it a much easier part to assemble onto the board, so it saves time and certainly improves performance dramatically.
Well, as a kudos to Samtec, when I decided to start this podcast and get a few key sponsors, I particularly chose companies that were leaning hard into good technical resources where people can learn not just about their products, right, but get those educational resources. And that's one thing I so appreciate about Samtec is the excellent technical resources that may or may not be talking about your product, but also teaching the principles. So I really appreciate that about you. Now, Steve, why don't we move away from the precision RF alignment and talk about edge launch, which always seems to be challenging.
And edge launch is great. And in addition to the verticals, which we promoted last year, we have a complete line of high-frequency edge launches that we're bringing to the show in San Diego next month as well. So we have a 1.85, which goes to 65, a 2.4, which goes to 50 gigahertz, and a 2.92, which goes to 40 gigahertz. But the good thing about the edge mount is the vertical mount is mounted at a 90-degree angle to the trace on the board. So that 90-degree angle is difficult in that transition to get great performance. The edge mounts are the best performing of the board connectors. So if you're using edge mount connectors, if you don't have to put it anywhere else on the board and you can use the edge mount, they're great performing products. And again, we're going to be showing those at the show this year. So
okay, great. What else will you be bringing to the show, David?
Yeah,
I know you're the product guy, so I'm sure that you've got your
the product
fingers
always
on the
gets
pulse.
It's always the exciting thing to talk about. I always love it.
Yeah.
as you've probably noticed, right, there's definitely a trend in a lot of what we're talking about, and it's always higher frequency, right? That's always a
Right.
subjective thing as well. A lot of what we've been talking about has been focused around, the test and measurement as well as what's existing within the market today. So that's typically caps out within, I would say, 90 gigahertz, about the max. Usually it's more in that 67. Um, Something that we are pretty excited about is a new product line that we've been working on to really answer the questions that engineers are going to run into within the next couple years, and it's what happens when you get above that 67 gigahertz
Hmm.
frequency range, and that's basically the answer today is a waveguide.
Hmm.
When you look at those frequency ranges, the exactly what Steve mentioned earlier, everything has to get smaller, which means the insertion losses get much, much higher,
Yep.
and it reaches a certain point where the product's just not usable, or they're having to use cable lengths that are very, very small to be able to get the signal through,
Mm-hmm.
and that's why they'll move over to a waveguide. And what we did was, and what we will be showing at IMS is a flexible waveguide solution. The goal of it was really how do you be able to offer a alternative to waveguide and an alternative to coax where you get the strengths of both as much as possible.
Mm.
So when you look at those coax solutions, they're flexible, they're very easy to use. The overall size is very small, so easy to handle, and density is never a concern. From the waveguide side, while it is rigid, it's kind of difficult to use in terms of aligning everything in place. You have to really set your system up around the waveguide to make sure everything's in place. But it gives you all the great loss performance, so you never have to worry about your signal not be able to make it through either in
Right.
testing or an application. So what this flex waveguide is basically offering the best of both worlds. That flexibility while still getting about 80% of the insertion loss performance that you would get out of a traditional waveguide solution. And so we'll be showing two different products there at IMS. It's going to be the V band and E band, so 50 to 75, 60 to 90, and definitely we see this being a product line that's going to kind of continue to expand within the frequency range, right? As automotive radar continues to increase, right? That's one of the big needs today within that 77 gigahertz range. But then also, you hear 6G talking about frequency bands, up into the less than 300 gigahertz range. They're talking about D band, which is 160 gigahertz. So I mean, it just continues to increase, right? There's got to be an end to how high the frequencies will get, but we haven't reached it yet.
Well, it always blows my mind. It's like, weren't we just talking about 5G like 3 minutes ago? It's
That's right.
just, it just blows my mind that we're talking about that. I was talking to your colleague Matt Burns about 224 gig. I'm like, weren't we just
Yeah,
dreaming about
56.
112 or 56? Yeah. And, as a PCB person, actually, I'm getting ready to do a podcast with Lee Ritchie talking about skew. And, he's like, well, basically, you got to get a Samtec flyover cable.
That's right.
And, and that's unsolicited. He's just like, well, the materials, they can't do it, and we just keep leaning in and finding the solution. It always blows my mind. Steve, you and I last year, if I recall correctly, you'll have to refresh the story for me, but you had done some kind of gang blocking application. I think it might have been a Mil Aero person that you custom designed for an application, but then you decided it was so great that you turned it into some kind of gang block solution, and you were just barely maybe demoing it,
Right.
like proof of concept last year at IMS. Where are you with that? And just update us on that. And is that something you'll be bringing in a more complete form
Yeah,
this year at IMS?
absolutely. We gave that product a name. We call it Magnum RF, but essentially it's a ganged version of our SMPM series connector, which is a push-on connector that goes to 65 gigahertz. But what we've done is rather than a discrete connector, we've taken the guts of an SMPM and instead of putting it in a single body we put it in a ganged block. So you can get a lot more channels or a lot more connectors in a smaller amount of space. So for high density applications, you now have this push-on connector where you can handle multiple channels in a small amount of space. So we have all different configurations now, from 1x2, 1x4, 1x6, 1x8, and 1x10 for both board-to-board and cable-to-board applications. And we're going to be bringing all of that product, and we have a demo at our booth for IMS this year. We also have a kind of a new version of that, which is the compression mount. David, this is really new that we've just released.
Yeah.
I'm going to let David talk about what we call it, our dually, but it's a unique product that nobody else has.
Yeah, we got some fun nicknames for them. Yeah, so it's exactly what Steve's talked about. Is it basically we're merging two of the product lines, and this it's the vertical compression that we talked about with those new alignment features, while using the advantages of that Magnum RF product line. So what it is it's a two-position vertical compression mount connector, and what this allows is kind of a nice offering, along with Bullseye. Bullseye's fantastic for those higher channel counts. What this really does is provides that usability that customers are typically used to seeing for the vertical compression, with the flange and the screw down being solderless. But then what this can do is provide basically 2x the density of what they're used to seeing for those vertical compression. So you're able to plug in with the SMPM instead of a 2.4 millimeter connector. You'll get two SMPMs in that same space, which is fantastic for, imagine if you're routing like a differential pair on your board, and you need it to go to a VNA. You can basically keep that differential pair coupled very tightly all the way to the vertical compression, this Magnum vertical compression, and then break out to your phase match cables that will then plug directly into your VNA. So it keeps everything as dense as possible for some of those lower channel count type of application needs. Differential is definitely one of them.
Okay, very good. Did you want to add something there, Steve?
No, that pretty much sums up our dually. It's a new product, and I think the unique thing about it is, everybody has a vertical mount. Other competitors have even ganged mounts now. There's other versions of that, but the compression mount dually type of product is just a Samtec only type thing. It's an original solution. And the other thing I might say about that's kind of where Samtec comes in. We think outside the box a lot. So we like to be original. We like to have unique solutions that our competitors really haven't done. So this happens to be right in line with that type of thought.
The thing that's interesting to me is that and I don't know this because connectors aren't my area of specialty, but what I like about what you're doing is sort of your customer centricity, is that somebody will come to you and say, I have this problem, and you guys will help them develop it, and then it may or may not become a product solution. But I love that your solutions are typically engineer driven and customer driven rather than, a lot of companies for different products, and they think they have an idea of what the user engineer wants, or they have a loose idea. But I think you guys, Samtec specifically, listens really well to what the market, what engineers are saying, where the rubber meets the road. And again,
we have a lot of resources, because
yes,
the waveguide that David mentioned earlier, the flexible waveguide, that came from outside. That idea came from outside of the RF group. It came from the high-speed digital guys. So again, a lot of these problems that these engineers are tackling now, sometimes you got to think outside of the box and out of your traditional way of how you've solved the problems at lower frequencies, and think along a different pattern. And that's where the Samtec having the resources of all these other engineers really came into play. And
it's all about the cross collaboration, right?
And by the way, as someone came from corporate America with multiple business focus and all that doesn't happen very often. It's like, mine, I get to win. I'm not going to share it. And you guys do this amazing cross-functional collaboration that makes everything better. So Again, kudos to you guys. All right. I know at IMS, besides products, you always do give some great technical presentations. What do you have on deck as far as technical presentations go, David?
Yeah, so one of them, we've talked about all the products and how fantastic they are. We can't do it without the engineers and the engineers' tools.
Yeah.
So we have one of our signal integrity engineers is going to be at the ANSYS booth doing a presentation on basically how we use HFSS to design and develop all these new high frequency products. So that's going to be a pretty interesting one. It's on Tuesday at 11 a.m. at booth 2135, which is the ANSYS booth. You can definitely learn a little bit more of what are the tips and tricks that are necessary really when you're starting to, work on this type of application need. And then definitely you would be able to incorporate that, with that white paper we were talking about on, wideband RF launches, combine those two pieces of information together and, you can be pretty dangerous.
Yeah, and in addition to that, Judy, I might mention we have Matt Burns, who you did the
Yep.
podcast with. He's getting together with some other folks in the industry from some other companies. And on Thursday, June 15th from 8 to 9:40 a.m., they have a presentation called Balancing Trade-Offs, Taming Signal Integrity Challenges in Millimeter Wave Antenna to Bits Implementation. And Matt's going to be representing Samtec. There's going to be someone there from Octava, MathWorks, Avnet, and Roden Schwartz. And they're basically going to be talking about, as from a system point of view, how all these components are interrelated and how they affect it, as well as examine some of the trade-offs and the interplay that you have between simulation models and real-world performance. So that should be something that folks would be interested in.
Well, and again, I just have to stop and pause and say, again, another reason why I like working with companies who see an ecosystem working together is the way to help engineers win. And now the speeds, Matt had made a point to me one time where he's like, yeah, it's too fast. We have to. We can't do these things in a silo anymore because the speeds are too much and we all have sort of a piece of the puzzle. So I'd love to see you guys leaning into sort of that ecosystem model and working with other industry partners to help engineers make those transitions, seeing how from a system level. Again, love it. Okay, we talked about, I know we're running short on time here. We talked about the alignment paper. Where else can we send our listeners and viewers to grab some good technical resources? Because you guys have so much.
Well, again, on our website, in addition to that, with all of our products, we have characterization reports. You can get actual 3D models of any of the connectors that we sell. So you can import that models into your own design if you're designing it into a system. We have that, as well as we have some references and some through our blogs and to some of the other resources that are useful to some of the engineers out there.
Yeah, and we have a tech library with all the white papers. We have plenty of videos and blogs, right? The Geek Speak videos that we like to share. We can provide you a link for that tech library, so your users will be able to see that. Also, if you want to get a little bit more information about that alignment feature on the vertical compression connector, samtec.com/alignment, that's a good resource to go to be able to learn more.
Good. I'm glad you shared that link. Saved me a little bit of homework. Okay, so you mentioned you're going to be at booth 2627 at IMS for anyone who's attending. Last year, I think you had a specific IMS landing page where people could go get everything and at one stop. I assume you're doing that again?
Yes, we do. We have that as well.
Yeah, so samtec.com/IMS 2023 or 23. Sorry.
Thank you.
IMS is 23, yeah.
Okay, and I'll put that in the show notes for all of our listeners so they don't have to go hunting, but thank you for sharing those URLs. Gentlemen, before I let you go, is there anything else you want to cover before I let you go back to work?
I'm just looking forward to San Diego in the sunshine and getting together with all of our I mean, it's like an annual reunion going to these IMSs because
Yeah.
it's the industry and you finally get a chance to see a lot of the people. It was a big show when we came out of COVID, and but
Yeah.
this show I'm pretty excited about because San Diego is a great area to go to. So
Well, let me just say on the back of that I just got to, I'm on the steering committee this year, and I just got to interview the co-general chairs, John Wood and Gail Collins, and it's going to be like drinking from the fire hose. And they did say we're back to pre-pandemic registrations, exhibit booths. So,
right.
who doesn't want to go to San Diego? So I think we're going to come back, full strength and really have a good time. And I wish you both great success at the show, and I hope to see you there. Hope you'll come over and see me at 1855, and I'll try to get over to Samtec and see everything we've talked about. Thanks so much for your time, gentlemen.
Sounds
Thank you,
good,
Judy.
Okay, we'll see you in a couple weeks. For our listeners, thanks so much for joining us today. I hope you've really been enriched, and hopefully you go check out the show notes and just dive into everything, not only at IMS, but product pages, tech papers, white papers, and I hope you find all those resources incredibly helpful. Thanks again for joining us. We'll see you next time. Until then, remember to always stay connected to the ecosystem.